Greetings. I hope every one of you are fit and fine and doing great during these challenging times. My prayers and best wishes for you and your family members. So in this video we are going to discuss about stationary points. First, the basics. What are the stationary points or turning points? I always believe that we must have some vocabulary about this topic. So what's the vocabulary for this topic? We should know what are the stationary points, turning points, what are the local maximum, what is the meaning of local minimum, global maximum, global minimum, inflections, stationary and non-stationary, gradient, and domain and range concepts. So stationary points are the points where the tangent is horizontal and gradient is equal to 0 always, and they are named as local maximum, local minimum, and stationary points of inflection. Let's look at the following graph. Now if you look at the points B and C, the tangent is horizontal and gradient is equal to 0, and the gradient changes sign from positive to negative at both these points. From on the left side of B, the tangent, sign of the gradient is positive, and on the right side of B, the gradient sign is negative. So therefore B is local maximum. At C, the tangent is horizontal and the gradient changes sign from negative to positive. Therefore C is local minimum. Now if you look at the other points A and D on the entire domain, A is the least valued point on the entire domain. Therefore it's known as global minimum of the function. However, if you look at point D, on the entire domain, D is the maximum valued point. So therefore, D is known as the global maximum of the curve of the function. Look at this curve, y is equal to negative x cube. At x is equal to 0, on the both sides of 0, gradient is negative, gradient doesn't change sign, and the tangent is horizontal and is equal to 0. So when the gradient doesn't change sign on both sides of a point and tangent and the gradient is equal to 0 at that point, we call that as stationary point of inflection. Similarly, let's look at this example, y is equal to x cube. The tangent at A is horizontal and gradient is therefore 0, and on the both sides of A, the gradient doesn't change sign and is positive. So therefore A is known as stationary point of inflection. Now let's take one beautiful example, examination style question from Hess Mathematics. Determine the position and nature of stationary points for fx is equal to sin square x for 0 to 2 pi. Domain is given 0 to 2 pi. We look at this graphically as well as manually. Let's write the curve as it is, find the derivative, that is 2 sin x cos x, and apply the double angle formula. It's equal to sin 2x. So now equate the gradient to 0, so sin 2x is equal to 0, but we have domain 0 to 2 pi. So here we have double angle 2x, so we'll change the domain to a new domain, that is 0 to 4 pi. So therefore reference angle for this will be 0. Now let's look at the values at which the sign will be equal to 0. As we have the new domain 0 to 4 pi, on the both sides, not on the both sides, we start from 0 and we take counting up to 4 pi, in which quadrant the sign is 0 and positive. So first of all, x is equal to 0 in the first quadrant we can say, or at x equal to 0, or in the second quadrant pi minus 0, so sin pi minus theta is sin pi, so that's 0. Similarly at 2 pi then again the second term, second quadrant, that is 3 pi minus 0, and then at 4 pi. Then we calculate the value of x. So x is equal to 0, pi by 2, pi, 3 pi by 2, and 2 pi, where the gradient is 0. Now let's discuss the signs around these points, signs of the gradient, which will help us to identify the nature of the stationary points. If you look at E, on the both sides of E, the gradient changes sign from positive to negative. Therefore, pi by 2, 1 is the local maximum. And similarly, at 3 pi by 2, the gradient changes sign from positive to negative. So 3 pi by 2 and the corresponding y value is 1. So therefore, it's also the local maximum. Similarly, 0, 0 and E, not E, we can say F, the gradient changes sign from negative to positive. And similarly at H, gradient changes sign from negative to positive. However, our domain is up to 2 pi. So these are 3 points which are local minimums. We can look at graphically as well. When we plot these points or the curve with the help of GDC, we find this type of shape. At point G, the point pi by 2, 1 with coordinates pi by 2, 1, the gradient changes sign from positive to negative. So therefore, J is one of the local maximums. Similarly, L, the gradient changes sign from positive to negative. So therefore, L is also the second local maximum. And 0, 0 is the local minimum. K, where the gradient changes sign from negative to positive, is also the local minimum. And M is also the local minimum. Let's see with the help of GDC. With the help of GDC now, the nature of the stationary points for the curve y is equal to sin square x. First plug in the curve y is equal to sin square x. So we can use the brackets for the sin square x. So sin x, close the bracket, whole square. So then go to window and we can adjust the window. Minimum value 0, maximum value we need 2 pi. So 2 pi. So then y minimum negative 2, maximum plus 2. So therefore we can see the graph of the curve. So we have 2 maximums and 3 minimums, because at this point where my arrow is right now, the tangent is horizontal and gradient is 0. On the both sides of this point, the gradient changes sign from positive to negative, therefore local maximum. And similarly at this point where my arrow is right now, the tangent is horizontal and gradient changes sign from negative to positive. So therefore that is known as local minimum. And similarly at this point where my arrow is right now, the tangent is horizontal and gradient is equal to 0. And gradient changes sign from positive to negative, so therefore local maximum. So in this way we have 2 local maximums and 3 local minimums, that is 0, 0, pi 0, and then we have is 2 pi 0. Thank you.